Okay, we're continuing on with mole conversions. So we're going to do 4 more examples here before we jump into protons, neutrons, and electrons. So question 24, we have 250 grams of magnesium hydroxide is equal to how many moles? So mole is mentioned once. I need 1 conversion. I have the unit of grams, so that means I need the molar mass of magnesium hydroxide, which we calculated up above, and that was 58.33 grams per mole. And so all we now need to do is do our train tracks going from grams to moles using a molar mass. So we start with 250 grams, put it over 1, gram comes down, mole goes to the top, 1 goes next to mole, 58.33, which is the mass of the magnesium hydroxide. Take 250, divide by 58.33, and I get 4.29 moles. 25, if I have 23 moles of tantalum, how many grams is this? Well, tantalum is an element, so I use the molar mass of tantalum from the periodic table. 1 conversion, because mole is mentioned. So I start with 23 moles, put it over 1, mole comes down, gram goes to the top, and then I get the molar mass of tantalum from the periodic table, which is 180.98, and then multiply those values, and I get 4161.85 grams. 26, we want to go from molecules to mass. So it says, what is the mass of that many molecules of calcium chloride? So mole isn't mentioned. I need 2 conversions. Molecule is a particle, so I need to use Avogadro's number. Then we have mass, so I need to use molar mass, and I have to use the molar mass of calcium chloride. And the molar mass of calcium chloride is going to be 1 times the mass of calcium plus 2 times the mass of chlorine, and that is 110.98 grams. So now I'm ready to set up my train tracks. 3.05 times 10 to the 23rd molecules. I'm going to put it over 1. Molecules comes down. Mole goes to the top. 1 next to mole. 6.02 times 10 to the 23 goes next to molecules. We're not done. We need 1 more conversion. Mole comes down. Gram goes to the top. 1 goes next to mole. 110.98 grams. Now multiply across the top, multiply across the bottom, divide top by bottom, and I get 56.23 grams. If you get like 10 times 10 to the 46th, you've done something wrong. You don't know how to use your calculator, so make sure you know how to use your calculator to get the correct answer. 27, what is the mass of 7.5 liters of oxygen at STP? Mole isn't mentioned, so I need 2 conversions. I have the word mass, so I need molar mass of O2. Liters and STP means I use molar volume, which is 22.4. So I start with 7.5 liters, put it over 1. I'm going to go to mole in between. Liter comes down, mole goes to the top. 1 mole is 22.4 liters. Then mole comes down, gram goes to the top. 1 mole is 32 grams because it's O2. 1 oxygen is 16, so 2 times 16 is 32. Multiply across the top, multiply across the bottom, divide top by bottom, and I get 10.71 grams. All right, protons, neutrons, and electrons. So we have a nuclear symbol, we have hyphen notation. So remember, this is a nuclear symbol, this is a hyphen notation. This number right here is the mass number, the number after the hyphen, which is protons plus neutrons. In the nuclear symbol, the top number is the mass number, and the bottom number is the atomic number. The atomic number is the number of protons. So for copper 64, protons, I have 29. because that's that bottom number, and that bottom number tells me the number of protons. The neutrons are going to be 64 minus 29. The mass number minus the atomic number, so it's going to be 35. And this is overall neutral. And remember, in a neutral atom, the protons equal the electrons. So my electrons are 29. Now, tin 118, this is the mass number, which is protons plus neutrons. So I have to look at the periodic table to get the number of protons, and that is 50. To get the neutrons, it's 118 minus 50, which is going to be 68. And this is overall neutral, so protons equal electrons, so I have 50. For the oxygen, this is how it should be written. Remember, the bottom number is the number of protons, or the atomic number, so I have 8. Neutrons is 16 minus 8. And electrons, well, I have a -2 charge, which means I've gained 2 electrons compared to the neutral atom, so which means I have 10 electrons. And then finally, magnesium, protons is 12, neutrons is 12, because 24 minus 12. And then my electrons, it's a +2, so I've lost 2 electrons, so I'm going to have 10 electrons. Now, to do the chart, we're basically doing exactly the same thing. Now, if my mass number is 14 and I have 6 protons, that means I have 8 neutrons. Atomic number is the number of protons, so that's 6. And then the charge is protons minus electrons, so charge is 0. Now, the nuclear symbol, we have to figure out what element this is. Well, it has 6 protons, so that makes it carbon. Atomic number goes on the bottom. Mass number goes on the top. There is no charge, so I don't put anything, and that is done. Hyphen notation is carbon 14, and the classification is an atom because it is neutral. Okay? All right, next one. If I have 6 protons and 6 neutrons, that means my mass number is 12. If the charge is 0, that means I have 6 electrons. Atomic number is going to be 6. And my nuclear symbol is going to be 14. No, it's not. It's going to be, excuse me, it's going to be 12 over 6 carbon. And then the hyphen notation is carbon 12. And because it's neutral, it's an atom. Okay, mass number 45, 20 electrons, atomic number 21. Well, the atomic number 21 tells us it has 21 protons. If it has 21 protons, the neutrons, it's going to be 45 minus 21, which is 24. The charge is protons minus electrons. Well, 21 minus 20 is +1. And then I look on my periodic table and I find out what element has an atomic number of 21, and that's scandium. Mass number goes on the top, atomic number goes on the bottom, and then I put a charge. And it's just going to be scandium 45. Typically, we do not put a charge in the hyphen notation. And then this is an ion because it has a charge. Okay, if I have 82 protons and 82 electrons, it means my charge is 0. If I have 82 protons, my mass number is 210. 210 minus 82 gives me my neutrons, so that is 128. My atomic number is same as protons, which is 82. And then I look on the periodic table. The element that has a atomic number of 82 is lead. And then my mass number goes on the top. My atomic number goes on the bottom. My hyphen notation is Pb210. And this is neutral, so it's an atom. And the 2 atoms that represent isotopes Isotopes are atoms of the same element that have different numbers of neutrons or different mass numbers. It's going to be these two right here. It's going to be carbon 12 and carbon 14. Okay, electron configuration. So you are going to have the diagonal rule on the back of your periodic table. You just need to use it. So you have to remember that the S holds 2 electrons, the P holds 6, the D holds 10, F holds 14. And remember, your abbreviated goes right in here: helium, neon, after neon, argon, krypton. And that's going to tell you where to start with your abbreviated. So the first thing you're going to do is you're going to look at the periodic table and you're going to say, how many electrons does each of these things have? So sodium, we get its atomic number, and sodium has 11 protons, which means it has 11 electrons in its neutral atom. Iron has 26, cobalt has 27, and chlorine has 17. And then to do our full electron configuration, we just follow the arrows. So the first 2 electrons go in the 1s. That can hold 2, which means I have 9 more that I can put in there. Then they go in the 2s. S can hold 2. 7 more. After 2s is 2p. P can hold 6. 1 more. And after 2p comes 3s. S can hold 2, but I only have 1 more to put in, so it's 3s1. Now to do the abbreviated, remember on the periodic table, you go up 1, all the way to the right, and you pull from group 18. And the base for sodium is going to be neon. Well, neon has 10 electrons, so I've used up 10 of those 11 electrons just by writing neon. And then I find neon on my diagonal rule, and I pick up with the next orbital after neon. That's 3s. Well, I only have to put 1 in, so it's neon 3s1. Iron has 26 electrons, so it's going to be 1s2, 2s2, 2p6, which gets us to 10, so I have 16 more. After 2p6 comes 3s2. Then I go to the next one, 3p6, so which means I have 8 more after 3p6. 3p6, 4s2, 6 more, 3d6. To do the abbreviated, I'm going to go up 1 all the way to the right. Argon becomes my base. Argon has 18 electrons. So by writing argon, I have written the electron configuration for 18 electrons. I have 8 more that I need to pick up. Then what I do is I find argon on my diagonal rule, which is right there, and I start with the next orbital after argon, which is 4s2, which means I have 6 more to put in, and then I have 3d6. Cobalt just has 1 more electron beyond iron, so it's going to be exactly the same. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7, and then the abbreviated is argon, 4s2, 3d7. Chlorine has 17. The first 2 go in the 1s, 15 more. 2s, 13 more. 2p, 7 more. 3s, 5 more. And after 3s comes 3p. Abbreviated, I go up 1 all the way to the right. Neon is my base. 17 electrons, but when I write neon, I've essentially written the electron configuration for the first 10. Then I come up, I find neon. The next is 3s. So it's going to be 3s2, 3p5. Excuse me. Okay, we come down. Now we do the orbital diagrams. The orbital diagrams are the arrows, and this is where we need to follow Hund's rule, which means we put 1 in each orbital before we pair up, and Pauli, which means it needs to be up-down in the same orbital. So I look at my periodic table and I figure out how many electrons manganese has. And manganese has 25 electrons and silicon has 14. So basically I add electrons until I've used up this many number of electrons. So 1s, up, down, 2s. Then I get to the 2p, I do up, 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 down, down, down. I've used up 10, I have 15 more I need to put in. Then I get to the S, get to the P, up, 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 down, down, down. That's 18. 4S, that's 20. And now when I get to the D, I follow the same rules. 1, 2, 3, 4, 5. And so that would be manganese. Silicon, I have to put 14. The 1S, 2S, 2P. Remember, we do up, 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 down, down, down. That's 10, 11, 12, 13, 14. And that would be silicon. And now part of electron configuration is knowing the capacity, knowing how many electrons each sublevel holds, each energy level holds. So energy levels, there are 7 energy levels, okay, which correspond to the 7 periods on the periodic table. There are 4 sublevels, your S, your P, your D, and your F. In the S sublevel, there's 1 orbital. Remember, that's like the room. And these sublevels are the wings to your building. And 2 electrons can fit in every orbital. The F sublevel has 7 orbitals, which means it can hold 14 electrons. The P sublevel has 3 orbitals, which means it can hold 6 electrons. The total electrons in the 4th energy level, well, 4th has an S, a P, a D, and an F. Oops, sorry. Has an S, a P, a D, and an F for a total of 32 electrons. And then if you follow your diagonal rule, after 6S comes 4F. Okay? All right. Life cycle of average and massive stars. I'm just going to tell you to go to the answer key. It's where you had on your web quest, you had the life cycle where you had those pictures you needed to fill out, where we had the nebula going either to a star or a massive star. Then it can go to a red giant. Then it can go to a nebula. So just look at that life cycle. You might want to put the order on your sheet of paper, just a small picture of that, and know the life cycle. And what is going to determine the life cycle is the mass. Okay, that is always going to be the most important feature or the most important factor that is going to determine the life cycle of a star.